All right. Hi, everyone. Welcome to another workshop from Mastering Backend. And this one, we're going to be looking at building and shipping our first MCP servers, right? Everybody here, we've all heard about MCP and the AI engineering buzz that is happening. And of course, we've also looked into it a little. Some of us have actually gone deeper into AI engineering. So if we have done that, we know that MCP is one of the most important things in AI engineering. We have MCP, we have agents, we have racks, all of this. So today, we're going to deep dive into MCPs and actually understand what it is, and then try to build our own first MCP server. But before I introduce the speaker, I always like to take our time to introduce everybody to Mastering Backend, right? Because Mastering Backend is hosting this particular workshop. And of course, we do workshops like this every week, trying to educate people on different concepts around backend engineering. But let's see what Mastering Backend actually is for some of us who doesn't know. Let me just do a very fast introduction. This is not going to take more than 2 minutes, right? All right, so Mastering Backend is, producing, or we are trying to produce job-ready, highly paid backend engineers. So that is our core mission. We want anybody that interacts with Mastering Backend to, at the end, become job-ready and, of course, highly paid engineers. So I'm going to explain to you guys later why I had to cross this backend. But our main focus as of right now is backend engineers, right? But of course, I'm going to show you the reason why I had to cross out backend engineer as we go on the presentation. My name is Solomon Eseme, and I am the founder and CEO of Mastering Backend. Before I actually started Mastering Backend, and I was a software engineer. So I specialized in backend engineering for a very long time. And today I decided to kind of, build Mastering Backend to be a platform that I wish I actually had when I was starting out. So a little of my story, I actually wasted 4 years learning the Java programming language. Most of us know Java, like we've written a couple of programs with Java, right? But the problem actually wasn't because of Java, right? So Java was the problem. Java is a very interesting programming language. The problem was actually in how I was learning Java, the method I was using to learn the Java programming language, right? So I actually downloaded almost like every Java tutorials and all of that. So for most of us that were learning around 2010, 2011, we know about the new Boston or Bucky Roberts, right? So he was a very good teacher that teaches Java. So I had all his videos on Java. And of course, you wouldn't blame me. I watched everything simply because he was a very good teacher, right? But the problem with that method was I was just watching these videos and, of course, trying to replicate what he was teaching by building exactly what he was teaching in those courses. Now, don't get me wrong, that is a very good way to learn. You're just starting out, all right? Following through with an instructor so that you get to understand, the flows and then build your muscle memories from there. But then it continued to a point that I always thought I knew something, but when it was presented to me without, any video or whatever, I would always mess it up, right? And then one day I had to decide that I was going to build a Windows calculator, whether rain or sun, right? Whether anything happens, I'm going to make sure that I build a Windows calculator. For those of us that have Windows laptop, you know that Windows calculator, right? So I decided I was going to build that application using Java. Now, that application is simple to do, but if you are starting out and you're always watching videos, you will notice like a dynamic shift when you decide to build something, whether it is a Windows calculator or any application at all. you will notice a shift, kind of, right? Because your questions are going to start changing from, what is this? What is this syntax? What, all those what if questions that teaches you theories. You'll start asking questions that are different, more like, how is this done? How can I do this? How do I do, how do I place a button in this particular point in, when you are building a window calculator, for example, right? So that kind of question or that kind of shift is everything when it comes to learning programming or learning anything at all. So if you keep depending on the knowledge of your instructor or the knowledge of your teacher, you are actually not going to grow. It may actually feel like you are growing, but you are not, because you are in something we now know as tutorial hell, right? So from building that simple calculator, it shifted my mindset to project-based learning system. Sorry, I have to add people. All right, so it shifted my mind to project-based learning. And one thing that I discover is that project-based learning isn't just going to make you better. It is actually transformational, all right? That is where the real power is, when you are able to take a project, dissect that project, and then build it out. No matter the different routes that you take, whether you sleep in Stack Overflow or you use Google, or now you use AI, of course, you actually achieve something, right? You actually build out something, and then you have a product, whether it is small or not. That kind of mindset is going to propel you to want to build more. And that is exactly what I missed when I wasted my 4 years learning Java. And that is what becomes mastering backend today, right? So the problem that I noticed, like I've already tried to explain, is, tutorial hell. Aspiring software engineers, even till now, especially in Africa, we still go through this somehow, right? We still go through this because right now we have endless content. YouTube is free, and a lot of persons are creating content on YouTube, right? People have different ways they are teaching, and you might not really get to know exactly the pattern or style that would suit your learning style, right? So you are just being thrown into YouTube or thrown into numerous resources. You don't have a direction, right? So there is a problem. And then we also have no practical experience. So we've seen over the years where people, have so much, skills on paper, but when you hire them or when they join your team, you see different flops because there is no practical experience when it comes to the core of backend engineering. And of course, if you are also, in tutorial hell and watching tutorial, you will have career stagnation because you will not be able to kind of, progress and get a better paying job. All right. So we have other platform. Why are we building Mastering Backend again? Okay, so some of the platforms that we've seen, what they do is that they actually sell courses, which is good. These courses are okay. Some of them are practical enough, and some of them are not. And then once you purchase this course, you notice that you are alone in that learning journey. You have to, because it's self-paced course, you have to finish it on your time. You don't have a limited way to ask questions and get personalized feedback. All right. The result of these is that you waste your years, like I did. I actually did waste 4 years learning Java. And then you have untapped potentials because, first of all, you wouldn't even know what is actually required in the job market, okay? Because you've always been hoping on the knowledge of your instructor or teacher in that particular course. And that actually leads to missed economic opportunities. Some of the highly paying jobs that you would have, gotten, you actually miss them because you are not practically in depth enough. All right, so what is actually the vision of Mastering Backend? So we are Mastering Backend. I'm actually building it to become a platform I wish I had, which I shared before, where anyone can learn backend engineering practically. So that is our core. We want you to learn this thing first, but we want you to learn it in a practical manner, right? And you can build real projects and you can actually grow into high impact engineers. Okay, so that is our mission. We have three things there, right? We want you to learn, and then we want you to learn it practically, and then we want you to grow. Okay? The vision is to empower the next generation of software engineers to solve real-world problems and thrive in the global tech economy. So that is what we want. So if you are coming into mastering backend, this is what you are coming into. You're coming to learn, and you're coming to learn it practically, and you're coming to grow in our platform. Okay, we also have long-term goals, a global hub for engineering excellence. Now, this is the reason why I had to cross the backend engineer that you saw earlier. The reason is because right now, we are focused on backend engineering, right? But we also have interest in other parts of engineering. Like we have interest in AI engineering, cybersecurity for engineers, of course. You know, while you're building the backend system of any product, there are different security measures and penetration testing measures that you have to take into consideration. And that is what our own version of cybersecurity for engineers actually deal with, right? And then we also talk about product engineering. We're also looking into really deep dive into product engineering, blockchain engineering, cloud engineering, DevOps, data engineering, and platform engineering. So these are some of the paths that you start seeing, you know, coming out in mastering backend. And that is why I had to cross the backend before, because now we are going into broad umbrella, not just talking about backend engineering, but the core focus right now is backend engineering. Now, what is the mastering backend solution? How do we actually do these things that I've just mentioned? All right. So we have this three parts approach or career transformational approach that we've spelled out. So the first one is learn, like I mentioned before. The second one is build, and then the third one is grow. So under the learn, we have structured ways for you to learn. So we have courses, of course. We have paths that gives you a sense of direction, you know, as you are learning. And then we have bootcamp, where you can actually interact with your instructor, ask them any personalized question that you might have. And then we have a platform, we actually call it MD projects, where you can build real-world backend projects, get feedbacks, and then see the preview of what you're building in real time on the platform. And then under the grow path, we have interview prep platform, we have certifications, and of course, very importantly, we have a community, we have mentorship, and then we have career placements, right? So the community part is where we are right now, where we are having this workshop, teaching you different things in the world of software engineering, and of course, this one, AI engineering. So I just wanted to make the introduction very quick. And if you have any other further question, please always send it to us at hi@masteringbackend.com. Thank you very much. Without wasting much time, I would like to introduce our speaker for today. His name is Idris. Personally like this guy. This guy is always on point, is the founder of Web3 Africa, and he has what it takes to actually teach us how to build and ship our first MCP server. So thank you very much for agreeing to do this with us, and you're welcome. So I will hand over the mic to you, and let's get started.
I think I'm muted. Thank you so much for inviting me, and thank you all for having me. So today, like he mentioned, we'll be looking at building our first MCP server rather. Let me try to share my screen. Okay. Yeah, I'm guessing it's bigger now. So thank you so much for inviting me once again, and thank you all for having me. In today's session, we'll be talking about building and shipping your first MCP server, but most importantly, we'll also go through some of the nuances, some of the architectural designs and patterns. And also, if you want to get started today, how do you start? And what are some of the lessons I've learned personally from building one, our own edge case? Why exactly do I need an MCP server? And then why exactly do I need it in a way that I end up building it? And I'm going to walk through all of these things. So if at any point you have any question, please feel free to drop it in the chat or call my attention to it, and I'll be happy to answer them. Or you can also wait to the end of the session so that we can go through any of your questions that you might have. So about me, my name is Idris Olubisi. I'm a developer relations engineer, and I currently work as a developer educator at Midnight Foundation, and also the founder of Web3 Africa. You can find me on all social media network. Most importantly, Twitter. You always find me there in case you have any other questions aside the questions you might have today, or you want to get in touch. So a bit more about me. Before becoming a developer relationship engineer, I've always been a backend engineer all my career before transitioning to DevRel. I founded Web3 Africa, just like I mentioned, and I've written technical content for series of organizations, both Web2 and also Web3. And nowadays, even the AI ecosystem, writing some content for some AI organizations that are interested in technical content, and also building how to build using their tools, or like combining their tools with an existing tool set that is currently out there. So what you learn in this session, a few things. First, we'll talk about MCP and also why you should care, and what does MCP unlocks for you. Then we go through like building your first MCP server, and then we talk about like common patterns. What are some of the things you should take note of? And also, if you want to start building your own, which one should you focus on most importantly? And then we then talk about like real world use case, where I go through like an existing MCP server, where you just see like the implementation, just to have more context on some of the things we might have gone through from MCP, talking about what MCP is, building your first MCP server, and also the common patterns. Then the important part is best practices, right? It's not just about building the MCP server, but also building it in a way that you follow industry standard, and also some of the proposed architectural design from Anthropic, from all of these guys that are already built an MCP server and also using it in production. Then I would then share like resources to keep learning. So after this call, you can go ahead and learn about building yours, and even dive deep, even beyond what I will be talking about today. So to start with, if you are hearing MCP server for the first time, that's quite okay. This call, we're going to go through everything bit by bit. But if this is not your first time hearing about it too, you also have some other things to learn, probably different from what you've seen online, around the jargon, around the hype on MCP server and all of that. So what exactly is MCP server? First, it is a model context protocol, which is an open standard for letting AI understand some of the tools that you have. And this was created by Anthropic. Anthropic led this whole idea, but then he went beyond just Anthropic. We have the likes of Google, the likes of other entity and other organizations that then support having a standardized approach that lets AI to talk to external tools and data sources. And I'm going to go through why it is needed in a moment after like this session. But then if you look at this, simplifies the approach of standardizing the way AI talk to external tools. But what are some of these external tools? Why do we even need external tools in the first place, and also data sources? There are different reasons, but think of it like think of MCP server like a USB for all AI, which gives them access to plug in into any AI model and tools. But most important part is that I think we have like three core primitives for MCP. So if you think about MCP server, you think about primitives like, which means that this could function as AI that can call additional endpoints. So if you build your own MCP server, for example, and then you add a tool, you can specify that tool to be able to call like an external endpoint. So an example here is, let's say, Flutterwave or Paystack MCP server or Stripe MCP server. If you are building, or if you look at any of them, I think Paystack have one MCP server and Flutterwave. If you look at their MCP server implementation and the toolings they have toolings that point to different API endpoints, like cash transfer, bank transfers, some of the actions that they have on their own server. So that way, it means that you can create an MCP server, specify a tool to make those calls. So what that means is that if I create that MCP server, and anybody on this call right now install that MCP server on their client, and then they ask related actions or questions like, buy me something online. The client is smart enough to use the MCP server through the tools available to call the API endpoint to buy that thing, right? So when I mean client, I'll be saying client a lot. What I'm referring to as clients could be Claude, could be Winsoft, could be your Cursor, could be VS Code, could be Cloud Code, any of those guys. That's what I'm referring to as clients, right? So any of these clients would have more context on how to make some specific actions or specific calls to any endpoint. If you have any endpoint that specify that kind of tool, then the other primitive is resources, right? You need to let AI understand what are some of the resources available for that particular action it's about to take. So if your client wants to fetch data, let's say you ask your client, how can I import something? Let's say, how can I use images in Next.js? And then you already have MCP server, Next.js MCP server integrated into your application or like into your client. What that system would do is now the AI needs to understand that, am I searching from my own data that I've learned, or there's any resources available for me? If you have resources available through your MCP server, then it helps the client understand how to fetch data for you effectively. And if you have the resources integrated in the MCP server that points to a particular file or a particular docs, the AI do not need to go online and start researching for that particular file or docs. You just go straight through the MCP server via the resources to go and access whatever doc or component or online resource that you've created for that particular action, and then it does learn from it. So this is quite different from tools because this is not endpoint. This is data or resources that you want it to learn from. And then the final primitive, the third part is prompting, right? So you could have reusable templates for common workflow. So an example here could be a React component for building an application. Let's say a React component for calendar, for example. Let's say you created, there's an existing React component for a calendar, right? And you know that that MCP that you are building is centered around React or front-end implementation. Then you can write a reusable template inside that MCP such that the client itself, once it's making a request through the MCP server, it's not checking online or trying to find the data. It just goes straight to the template and pick that particular template for React components that is related to calendar. In this example, right? It could be for any other thing. So the good part of MCP server is that while you have tools and resources, you can also have existing prompts that can be that can serve as something reusable for common workflows or common actions. So you don't have to reinvent the wheel, and also you're also helping the clients to get response and get smart enough to understand what it takes to get response for that particular action that you're asking it. Don't worry if this does not really make sense, but we are going to dive into more scenarios for you to understand what I'm saying and how does it even look like under the hood. So now, let's talk about the problems MCP solves today. So it was created, and then now we know what it is. But what exactly is it solving? Why do we even need it that we now have to start thinking about tools, resources, and what we should learn about it? So before MCP, we have so many AI tools that are out there. Everybody's using a lot of tools. But there are three key things that I called out here right on my screen. Is the first problem is that every AI tool had its own plugin and plugin format. So every AI model or toolings out there, they create their plugin, they share it to the world, everybody is excited, and then they all have all of these things, which means that every tool, so if we have 100,000 tools, a particular tool can have 100 plugins. So that means 100,000 tools. If we assume on average that 100,000 tools have 100 plugins, then it means that we will be dealing with 1 million plugins. Now imagine a company is using, let's say, 10,000 tools from those 100,000 tools. See how many plugins they have to deal with, or see how many plugins the system have to use or realize or to use independently for individual tools, because they are not the same, because they are different plugin formats. Also, if you are familiar with ChatGPT already, ChatGPT plugins is not the same thing as LangChain. It's not also the same thing as some other custom tools or any other tools or agentic solutions that is out there today. Everybody is doing their thing differently, and it works for them really well. But there's no standardized approach of getting all of these things to work together. Another one is like a number of AI app multiplied by the number of tools, which is just a scenario of 100,000 that I mentioned, like having 100,000 tools available, and on average, each tools have 100 tools. So it makes it difficult because now you need to multiply together, which means that for an existing workflow or architecture to work, you need thousands of integrations to happen. But then when MCP came into play, the first thing that it first solved is standardizing the protocol, such that even if you are using ChatGPT, LangChain, Claude, any of these guys, any of these clients, if you are using them, they still have a standardized approach such that you can remove one and plug in the other, and the system still work the way it's supposed to. So what that means is that you can build once and everything just works anywhere. And I don't know if you're already familiar with using MCPs or using AI agent or agent toolings or any of these things. You realize that most of this implementation or these toolings available now, you can swap out like different clients. Let's say you are using Claude endpoint or Claude access or resources, you can swap the URL out to ChatGPT or to something else. This is because of this standardized approach where swapping out does not really change any flow. You just change the endpoint that it is pointing to, and you can just continue to use it. But if one thing I want to call your attention to here is that if you now notice the formula of N AI apps times the M tools, instead of it resulting to N times M, which gives you ridiculous amount of integration for a particular workflow, it just makes it an addition. So it means that even though I'm swapping the URL, I still get access to this. And using MCP even makes it much more simpler, such that every client makes it easy for you to access a particular resources, irrespective of that client. So if I'm swapping Claude for Windsurf or for Cursor, I still have the same experience to interact with any model or any resources or any toolings that is available for me, right? Try to remember these concepts and it will help you understand the rest of this talk today, because everything has a reason, and it's then once you understand the reason, every other knowledge base that you need to know about that thing then builds upon that particular reason. And as you go into MCP server integration, building your own and all of those things, you then understand even more how to build them and why they exist in the first place. But let's look at, I talked about integration and everything. Let's quickly look at the MCP by numbers, right? What do we have there today? There are a lot of MCPs out there, and according to statistics, we have over 97 million plus downloads monthly. Since the launch in 2024 December, we've seen growth month in, month out, like weekly basis. And we also have over 10,000 plus public MCP servers. And that's also the good thing, right? It is not gated. It is usually public, right? Once somebody build an MCP server, for example, the Figma MCP server is public. It has a lot of download, a lot of thousands of downloads and stars. You can easily access it. In fact, you can clone the code. You can learn how the implementation works. You can use it to build your own if you have similar pattern or related patterns. Those things are out there and you can use it today. They are more or less open source for you to start building. Another one is, I talked about the stars already, and also the packages that are available. From the launch to now, we have a lot of downstreams down the line. And then you also if you look at the way MCP servers are built today, and then how it connects to like different packages out there. According to statistics, we have over 36,000 package dependents on a particular MCP server, or either MCP server, depending on some of these packages to run effectively. So it is not a thing of, yes, it is new, people are building it, but it's being heavily used in production. And that is why I would like anybody listening right now or watching to try after this call to, play around with some examples that you might find online and see how you can use that experience or knowledge to build for your own personal sake or for your company or for a project that you represent right now, maybe as a developer, as backend, frontend, or whatever. It is quite similar approach, and then you can get started without any problems. But let's take a step back and look at what the anatomy of an MCP server looks like when you want to dissect, oh, okay, how does it work under the hood? First thing first, the AI client. So we have the AI client, which is Claude, Cursor, VS Code, Windsurf, any of these clients that you might be familiar with today. That is the first part of activation because that is the end user side of things. That is the first thing you see. Then the AI client would make an RPC, JSON RPC call to a particular MCP server. Let's say you build an MCP server. So this is where your MCP server comes in into the, now your MCP server comes in, your MCP server have a lot of tools like underneath. That tool serves as a function call that your AI can call, right? And it also have like resources, just like what I mentioned earlier on as part of the core primitives. And then it has prompts. So all of this thing is embedded almost automatically into the MCP server architecture and what the MCP server is offering by default. Then after it hits the MCP server, what the MCP server then does is to fetch and execute. So the flow now means that if your MCP server is somehow connected to an API or services or database, the AI client do not need to check any other place. Once it goes through the MCP server redirects it correctly to the appropriate source, either through the toolings or the resources or the prompts, and fetch whatever data that needs to be fetched and execute that data through, if you have a backend endpoint or API, get all of these things and take it back to the client. Mind you, let me clarify something. MCP server does not have a model. It is a context protocol. It is not a smart model itself. So what do I mean? You can interact with Claude today and all of these AI clients. They have an existing model and they are smart enough for reasoning and doing all of that. That is why they exist in the first place. And the client is how we were able to access them, right? But on their own backend, without MCP server in the picture, on their own backend, they have a model they interact with. So if you ask them things like, what is my age? And you supply some information, they can give you context. They are smart enough to do all of these things. But MCP server does not have a model. It's just a context protocol that connects to tool and resources to your client. So if your client is asking something like, let's say I have Figma MCP server, and then you type in on your client, like design a landing page for me in Figma, and you have your Figma MCP server. In the Figma MCP server, they would have a tool that points to resources that can help anybody or the agent or the client to build something related to landing page, right? So because the client is smart enough, the client can now route through your MCP server to go and pick all of those tools and use it to create that landing page for you. So it will be a back and forth between the client and the MCP server till you get the results back on the client. But it's also important to note that during the process of interaction, it is between your client and the server and the MCP server. So if you remove the MCP server, it means that you are telling your AI client to go online. By default, they don't first go online. They check through their model, the memory context they have for that particular thing. And some of them are trained to like last year or 2 years ago. So they don't have like up-to-date information. So what they do is that when they check that model first, their own reasoning first, their own base knowledge or knowledge base, anything they find from that, if it's enough, they go ahead and do whatever you want them to do. But if it's not enough, they go online and research. And sometimes they prompt you that they want to go online, or you just see it on your clients that they are searching online for that particular thing. And then they get back to you, right? But with MCP server, they don't have to search online randomly, because now at that point of searching online, they might hallucinate and do all of those things. But with MCP server plugging into that process, when you request something like, help me design a landing page using my Figma or in Figma or whatever, what the system does is go straight checking, using like thinking like, oh, what do I need to build this thing? And then once he wants to make that request, if you have your MCP server, the Figma MCP server integrated to your client already, it goes through that MCP server. And then the MCP server shows, hey, I have a couple of tools that might allow you, like help you to build this faster. Then it looks for the tool. Oh, is there a tool for building landing page? Okay, there's a tool. Is there a tool for color picking for the landing page, text, font? If all of those things exist, then it just goes straight and utilize those two and then come back to you with the result. So the system do not have to really check their own model reasoning, except they have to. They don't have to go online. They are smart enough. If they find things in your MCP server and it is not enough, then they can go online to enrich whatever they found. So the starting point is not really online. The starting point would be either their model that they are trained on, or the MCP server. So once they get all they need there, you can even watch side by side and see the differences between how things get called when you have MCP server and how it gets called when you don't have, and you just have like an online. You will see the clear differences because it won't be faster, and you are most likely not going to get like the appropriate result that you need for that particular action. So I just wanted to clarify that. So this is how the flow works from the client to the server and to the execution layer. So building your first MCP server, it is very simple. But obviously, everything starts from hello world, right? Before you now start building on top of that hello world. But if you get the hello world wrong, you will never understand anything that comes next. So that is why I'm using this example, the simple MCP server. And if you watch, we have two imports here. The first one is we import from the model context protocol, which is an SDK that is publicly available, that was published by the Anthropic and the other team that worked on MCP server itself. And then you can see we are importing the JavaScript file. And then the next one is the Studio Server transport that helps with the communication between your client and that MCP server. So it allows like calls from all of these clients. So when you have that, you then have you initialize your MCP server and you can give it a name, the version, and all of those things. This is very simple. Now, if you notice this part that after initializing that, then we are making a request. We are creating a tool that makes a request to hello. And then we are matching that tool to hello. So anytime you say hello, the system responds with something like, hello, your name, right? And then if you notice here that it takes in name as the string, like as the value. So the expectation is that the system understands who you are in relation to the clients that you are using. So let's say you sign up on Cloud, for example. You signed up, you put in your name, you are on subscription, you're on free version, whatever it is. Somehow that desktop or that client knows who you are. So that is the kind of content that is going to feed into your MCP server. And then when the client hits this particular tool with hello, it returns a text saying hello with the name that was supplied by that particular client. And all of these things happen automatically, but this is what you can control here, which is your MCP server. So you can redefine how this tooling works whenever somebody says hello or whenever somebody says something. You can see hello here means say hello to someone. That this is just a description of what this tool looks like. And I mentioned earlier on that to call the three primitive is to resources and prompts, right? This is just one of them. And then you return it because now you want to be able to connect to whatever client that is making that call. And then you can just automatically bind your transport to the server. And this is how simple it is for you to create your own first MCP server. But don't get me wrong, this is the simplest version. If you look at some other MCP, they might have abstracted some of these things to different file, and it might also be like very robust. But the whole idea is just centered around what you are currently seeing on the screen. So I think I already explained what is going on. But the first thing, just to double down on that, is you create a server with a name and the version required by the protocol. you register the name of the tool. In that case, we register hello and the description and the input schema for validations and also other things that would help that function. And then we connect via the STD IO for the system to be able to read from STD in and write to IO so that the cloud desktops can talk to it. So it's cloud desktop in this example, but it could be Cursor, any other thing that is out there today. So what does it look like connecting to the client or the desktop that you are currently using? This is how simple it is. So if any MCP server out there, if you want to utilize them in your project, you want to import them or install them on your machine or on your client, this is the same approach that you mostly use for all of them. In fact, some examples that you might also see out there is that some of them might not have a part, some of them might not have something like install. This is how you should install it. But then, sorry, let me take it back. Yeah. But then they will always have a part for you to install. So if you are doing it locally, then you can have parts to your server.js, which is the server that I was showing not long about, the simple version of MCP. But if not, you have a part to like an NPM package that you can install from here. But this is similar approach. And once you configure it once in your JSON file, either you are using Claude, you are using Visual Studio Code, you are using any of those two, once you configure it once, you are good to go. And then the system starts to use the MCP server under the hood whenever you want to make a request, especially through any of your clients. So it's important to know that there are two parts to it, right? If you want to build your MCP server, there are two parts you can pick. First, the high level part and the low level part, right? But then what is the high level best for if you want to quickly get started in building? The first thing is getting started and having a very simple server. But for low level, if you want to build in production and you want to have like a full control, which is most use cases that you would see in a production like environment or production build base for any of these MCP servers out there. Another one is tool registration. You can see the way I registered the tool already. You can just go ahead and follow the same pattern. But when you are implementing in low level approach, you need to always set like a request handler, because you don't want to, sometimes it's not tool, sometimes it is resources, sometimes it is prompt. So you want to make sure that you cover all of these use case when you build your application. Another one is validation. Zod is the biggest validation layer that you can utilize and you can just get started quickly with. And then the other one is manual. If you want to have your own robust validation or your own custom validation or validating data that is coming to and fro of your to and fro from your MCP server. And then we have the primitive dimension, which is tools, resources, and prompts. But if you want to do like low level implementation, you can go ahead and add things like login, completion, progress. I don't know if you have seen using any of these clients for progress. You sometimes, you see something like combobulating, specifying, all of those things are like, they don't want to keep you waiting with a rolling icon. So they want to just keep you engaged whenever their AI model is doing anything. So you can implement that particular engagement into your own MCP server too. So when they make a request and your MCP server point to a tool and it's still being in progress, you can have something like progress tracker that tells you, hey, this is currently here, this is at this stage, and your client will be showing it for you on your own clients. You can see all this interaction between your client and the MCP server at every point. You can also have sampling, you can have subscriptions also. Maybe you have something, you can create I don't want to say WebSocket, but something like a subscription like thing that whenever anybody requests for this action, the client subscribe to it till the action is done, and then they get a feedback back. So that way, subscribing to it gives them access to monitor that particular thing, and once it is done, they get notification. And then it's also important to know that you have like this high level one is like a quick prototype that you just want to do and test out, which I always recommend as the starting point. And then for production level, an example here is Midnight MCP, which is an MCP server I built myself, and then some other production servers like Figma MCP. There are a lot of MCP out there that people are using quite heavily and is really helping life. So those are the parts, but let's talk about the three architectural patterns that would help you when you think about MCP servers. The first one is you can have this single script approach style where everything is in one file, which is good for one or two, three tools, but obviously this is very minimal. Then you can have the module-like pattern where you create tools and those tools are separated by different files, different imports, and then you now then import all of them into the main file. This is just a design pattern. And then the last one is the modular, the domain modular pattern, which is the production pattern, where each tool category is a full module on its own. So they have things like schemas, handlers, definition, validation, all of those things, right? Just the way you would always abstract your backend implementation if you have things, right? Imagine you writing your node servers yourself, and then when you bring in Express.js or Nest.js into the backend, how you can then abstract and do more things. Then after abstraction, you then go ahead and start doing like domain-driven architecture where you want to have like separation of concern. You also start to think about monolith and microservice. All of these things are based on how robust and production-like that you want to use it for. You can always pick any of these patterns. So this is what these three patterns looks like: the single file, the grouped file, and the domain modular approach. So a case study here is where you can see like everything put together. And an example here is Midnight MCP server. So it could be any name, right? In this case, it's Midnight MCP because it's a Midnight blockchain that we're using. So it could be Figma MCP, Paystack MCP, or any of those things. So if you scan this QR code now, which I will encourage everybody to do, it's going to redirect you to a particular application and you can share from there. Let me try to grab the link. I think I shared it initially. 1 second. So if you scan this QR code, it's going to redirect you there. But for the sake of you guys, I want to share the link I created earlier on for it. Yeah. So let me share this. Yeah. So that's the link. You can check it out and see this implementation pattern that I'm talking about, and you see like the production level. But I'm also going to go through what it then looks like. So now for this particular case study, what you would find in this particular MCP server is you see tools. Today on that particular MCP server, you have like 29 tools across 6 categories, because students can also be categorized in the implementation. So you can have tools for just user settings, you can have tools for financial records, you can have tools for data recovery, you can have tools for managing user profile, password, and all of those things, depending on your application that you are building the MCP for. So you can then categorize them depending on their use case. Right. Then for resources, in this particular tool, there's 9 resources available. There's the static and the dynamic. So I'm going to explain what that means. So the static one is, let's say you have a package. Let me see. Okay, let's say you have a package that's a JavaScript package or an NPM package or whatever package it is that does one thing. Let's say a package that does like UUID, for example, right? And you want your MCP server or any AI clients that is using your MCP server to be able to build a UUID based on that your package. So you have 2 options. It's either you implement that approach of doing your own UUID inside the MCP server itself, or you have the implementation somewhere that you integrate as a resource inside your MCP server. So whenever your AI clients make a request to create a UUID, the system just if it is static, it pulls it back. If it's not static, it goes back and then call it dynamically with any template that you've defined there. Then for prompts, you can have, in this example, we have 5 workflow prompts where every workflow like creates, read, all of this action, depending on what you design there, is being used on. Once you have this example has 5 prompts. So these 5 prompts, your clients can call any of these prompts, and any of these prompts have access to other resources and other tooling. And then the architecture used in this example, like I mentioned previously, in the type of architectures or the patterns that are available is modular, domain modular architecture, where we have the schema, we have the handlers, and then we have the tools. And also this approach implements the transport layer also, which combines the STDIO plus the HTTP. So it's your client has two options, either to connect via the STD or use a streamable approach with the HTTP route. And then we also have validation layer, 3 validation layer in this implementation. It does ZOD, sanitation, and also business logic. So depending on how you choose to write your implementation, but these are some of the standard industry practice that you would see out there for MCP servers in production that are heavily used. These are the common patterns. And also, there's also YAML by default implemented, which this helps reduce the number of tokens that you're using. Because remember that when you ask AI to do something for you and you have your MCP server integrated, sometimes there will be back and forth between AI, the AI client, and the MCP server. You might not see it. You might only just see a single line tracker just showing that you have MCP server and there's something going on between the server and the AI client. But sometimes a lot of tokens get consumed in that back and forth that is so unnecessary. So in this application, in this use case, there's a design such that there are some YAML implementation that saves you almost 30% of token in that process of back and forth between the AI client and the MCP server. So that way, that YAML have some default that tells the client automatically. So the client do not have to hallucinate in that process. It just goes straight using the YAML file, and that will save you a lot of tokens. 30% is not looking like a lot, but it's a lot, even if, especially if you're on a free version of any of these clients that you are using, because token gets used almost instantly and then you will hit rate limit in no time. But with this MCP, if you are using it, you can be assured that you have almost 30% token savings for every call between your client and the MCP server. And then these also have caching. Like I said previously, everything starts from hello world, right? The simple MCP server that I showed you the example is just the starting point. This one has caching in such a way that it could help AI clients to get some data faster without having to redo it. This also has testing implemented with different test suites for whatever you've implemented in your MCP server. It also indexed. So this is one critical part, right? Why you should find a way to design your MCP server such that it's quite usable. So before building this Midnight MCP server, one of the things we've seen is that Midnight supports like a different programming language, and AI mistaking that programming language, which is compact, for TypeScript because they kind of look alike. So if you don't use this MCP server as AI, it is going to sometimes get it correctly, sometimes get it wrongly, and still tell you with confidence that this is correct, right? Unless you know what you are doing. So that's one of the biggest complaint that I've gotten and seen myself. So I was thinking about how can I make it even smarter, such a way that I'm not just pointing it to tools and resources alone, but it's smart enough to know the differences between TypeScript and that language, and also smart enough to detect it. So now I'm saying AI client is smart enough, not the MCP server. So whenever AI client asks a question, maybe you ask, oh, I want to build this thing in Midnight, right? AI client goes straight, and then through the MCP server, it tries to look for tools and resources, and then comes back to you. Anything that is available is what it is going to use. But during the process, it might also hallucinate and use something else. But the reason why we have something like index data that is using a Cloudflare workers, you can choose not to use these two, the index data and the modes, right? And everything will still work fine. But you have high chances of having a dumb MCP. These are some of the things that makes your MCP smarter. Mind you, this is not a model. This is just making sure that the MCP has more access to more resource for that particular thing that you're building or that product you're building for, such that at almost 90 something percent, rates, your AI clients will never hallucinate with something else. So in this case, we index over 100 repository in the Midnight ecosystem, which is like a huge knowledge base for your AI to see what other implementation are available, and then the AI client find all of them through the MCP server without having to go online and start surfing the internet for this implementation. And you know, sometimes once you're solving internet, some of this implementation might not be indexed yet. So the system might also miss out. So, but how do you index this repository? Are you supposed to index it? Sorry, are you supposed to index it on the file itself, on the MCP server itself? No, of course. You want to index it somewhere that the MCP server can get access to. But how do you index it? Is it that you are just storing the data and then they get it? How does the system read faster and read all of this? That's why you now vectorize it. So there's something called, like, you can vectorize it in such a way that that index repo is saved in ones and zeros. So if you are familiar with how vector DB works, that's exactly what it is. So if it is saved in ones and zeros, it means that once you index it, when your API clients, AI clients makes that call, they can understand ones and zeros, and they just go ahead and match that ones and zeros against whatever you have indexed from the repository. In this example, it is 100 plus in repository that has been indexed. In some other examples, which I rarely do not find out there, because most of the MCP you find out there are just like MCP that points to tools and resources alone. They don't really have like a knowledge base where they give access to the MCP server to learn more about their product, because probably it's not their use case, right? And then the modes here, in this example, it is, if you are running it locally, it uses ChromaDB. ChromaDB there's a Docker image that is free and open source. So if you are testing locally, you can use ChromaDB. ChromaDB does the same vectorization that you would use on Cloudflare workers. And you can use any other thing that supports VectorDB just to host your index repo, so that your MCP server remains very light in kilobytes, so you don't have to store it on the actual package for the MCP server. So there are a lot of resources out there, but these are the ones I feel like if you go through them, you find it really, really helpful. And I'm also going to share this slide with you guys, so in case you need it. So these are the actual model context protocol repository, where you find the TypeScript SDK, the official server collection, the build guide on some of the things that you should know during the process. And of course, if you already scan this QR code, you see how this implementation works. You can feel free to style it or clone it, learn about how it is work, or just build your own side by side with it and learn some things that were implemented in this MCP server. And you'll be you'll be good to get started. Yeah, so that's pretty much it for today's session, where we talked about building your own first MCP server. And this is also another QR code. It takes 1 minute, less than 1 minute to fill in. Let me know what you think about this presentation. If you find it useful, if you were able to learn a thing or two or not, just let me know. I try to manage time a lot here. I would have gone even more deeper, but I would need nothing less than 2 hours. And I don't think that might be helpful here. That's why I try to cut it down and give you a use case that you can try on your own. But if time still permits, I can share my Cloud code, my Cloud desktop, and put some things into practice, and you see them in action. Thank you so much. Yeah, for having me.
All right. Thank you very much for that wonderful presentation, Idris. I honestly really learned a lot from the example that you gave down to how you walk us through the beginning part of MCP, making us understand what it actually is and why we actually need it, and then showing us, the projects that you've built and how elegant it is. I really appreciate that. And thank you very much for coming. So now is question time. So we are going to take a few questions, because I think it's more than 1 hour. So we're going to take a few questions. And of course, you can always ask more questions to Idris. Look at his Twitter handle is here. So you can always ask him questions personally, or you can send the question to us at MasteringBackend, and we are going to address it. So I would ask like 1 or 2 persons to maybe raise their hands, ask their question, or send it to the chat and I will read it out to Idris. So who is going to be the lucky two? All right, Chibuzo, let's hear you.
Hi, good evening, everyone. Please confirm.
Loud. I can hear you. I can hear you.
All right. Thank you so much for the session. It was very insightful. So the question I want to ask is, so for the MCP server, how is it being, like how do you host the MCP servers? When you look at MCP servers like Figma, Firebase, how are they being hosted? Is it the traditional way you kind of host normal application? Then the second one is, so when the client, as you mentioned, is interacting with the MCP, is there like a documentation that it uses to know, okay, this is what to call, or I don't know how it's able to just consume that information. Those are the questions I have. Thank you.
Yeah, that's a very good question. Thanks for asking that. It's just time that did not permit. I should have gone hands-on, really, really hands-on. But when you talk about your first question about hosting, right? Lucky enough, we have NPM package. You can host your MCP as NPM package. So for the use case that we went through, you can see this MCP server being hosted here. So once you run this command or you set it up the way I mentioned during the presentation, we are using npm.js storage. But if you also notice that the file is just kilobytes, right? It's been bundled correctly and very, very light. So this is where everybody on Earth that are building MCP server hosts their MCP server, mostly on it's been published as npm packages. And then you can, in this README, there's add to cursor button that you can add directly, or you can manually add it. There's VS Code. You can see the same approach of adding, depending on whatever tool that you're using, and also some other information about the tool here that you can find out. That's your first question. It can be mostly hosted on npm package. And then the second question on how to find it. If you look at this repo, oh my God, let me share my entire screen. 1 second. Yes. So if you look at this example that I also gave earlier on, this is the implementation of what I was asking you guys to scan and all of that. On how resources are being fetched, there are different approach to it. There are some that might be static, which is like templated, and there are some that are like endpoints. So depending on your use case, in this particular example, you can see, so you don't have, the API part is the vectorized part where the system does a semantic search. So why does this exist? This is for just additional knowledge base. So this is where the 100 repository gets indexed on the Cloudflare workers, and the MCP server have access to it, right? This is just number one. Number two of storage on how they find data. And also we can go through these docs to see how the architecture and everything works. But number two of the storage is, 1 second, let me see. Yes, so you can see in this implementation, we have the same thing I mentioned, the prompt, the resources, and the tools. So if we look at the resources, you see that there's content. You can also like hard code some of your data statically here, so that whenever the system wants to ask for something, a repeated pattern. For example, if you look at this code content, it's just a pattern on how compact programming language is written. So what you are doing is to guide that particular client on how compact is written. So if you are doing for Figma also, you have your own approach. Let me say Figma, because Figma is not a programming language. Like Figma is for design, so they have endpoints for toolings to call for all of these things. But for Java, let's say Java has Java MCP, for example, or Go, I think Golang has Go MCP. So it's still the same thing. If you want, you can just quickly create like a rough skeleton of how the programming language works here. So you don't need to store like the entire data. Remember that AI clients, the Cloud Cursor, they have their model and then they are smart. So what they just need is guidance, and then they can take it up from there. So you don't have to store like word for word, back to back, and everything there. And you as a user, me as somebody that have written compact programming language, all of these things do not really make sense to me directly, because they cannot work directly if I copy and paste them. But it does make sense to the AI client that you are using, because there's so many abstraction here. We are just guiding it that, oh, you can write ledger like this. You can write, just like, oh, you can write Java like this. You can write hello world like this in Java. So he just needs an example, a very small example, then he takes that for learning. So because it is going through MCP server, it will be faster and he doesn't need to go online and start looking for it, right? And also smarter. So that's for content. That's one way of saving resource. Another way is toolings. Also, you can point it to repositories. You can see, in this case, we have so many repositories that is being pointed to. This is one way of doing like a tooling. And if you look at this, I'm not explicitly calling out the URL. I'm just telling it the repo because the AI client that you're using can understand it enough. Once it sees this is the repo, everything, it sees the entry points that, oh, the repo is this is the name of the repo. It just goes straight to the repo and pull whatever he needs from that repo readme or the entire repo file. And then we can also see like the schema, the tools, sorry, the index, the handlers that it needs to get those information. So these handlers are very important because those are the directions or like those are the things that guide the call from the client to the MCP server. So storage, when it comes to like, okay, I've talked about storage. When it comes to like accessing information, all you just need to do is to like create tools for it as a guide, and then the system then understand. Again, MCP server is not smart, is not a model system. The client has the model, the client does the reasoning, right? The cursor clients, the Cloud client, they do the reasoning themselves. But the MCP server guide them on which call to make, how to make this call, the direction, and all of that. So I hope that answers your question.
All right. So please let us know if that answers the question. Just drop an emoji. But let's go to Ed.
Ed, please go ahead.
Thank you for having me. I want to ask, how do I handle timeout between MCP server with my client in production? Because like yesterday, I was interacting with an MCP server I built in Python, but when it takes a long time, like that, it passes my timeout, it now shuts down. So I don't know if that happens only in local or
Yeah, I've also experienced that. So there are 2 to 3 ways I end up implementing it for this particular repo. I've experimented with a couple of them. I think the first one is for that to fix the timeout. You can either shorten the data that the system is trying to read that is taking a lot of time. You shorten it in such a way that instead of having like a bio, let's say you have a bio that says that have like 3,000 lines. Instead of mentioning the 3,000 lines, you shorten it to 3 lines, but then each line will now point to an external resource. So that way, if the system is reading a single line, they can be able to get it from the external resource and await the response without having to synchronously wait for it until it's completed. That's one of the reasons why the timeout occurs, because it's trying to learn a lot during the short period of time. That's number one. Number two is also like most of these clients limit the time a particular socket is open. So you have to, I can't remember the exact figures, but if you Google it, you see it, you have to see the time that it takes for their request to complete and try to reduce your implementation per calls. So in your tool, if your tool is calling sub-action, split those two into very light tools so that the action or the request can be completed in that particular time frame before it times out. Because that's also another thing, that you might have a tool that does, let's say you have a tool for profile settings. A profile could have a lot of settings like updating their username, updating their email address, updating, do some other user action on the app, and everything has like endpoints. And you just created a single tool for user settings. If the client wants to call the MCP server and get a request from the profile settings, it might take a longer time because of all of these other things that is happening. So what you might want to do is to split that particular tool into like 2 or 3 tools. It is still going to be under user profile action, but different tool categories for the actions there. So that way it can restrict the time. That's number 2. The number 3 that I've also tried is asynchronous execution, right? So instead of having to statically make your MCP do something on the MCP server itself. You point it to a URL or a resource for it to do it. So I'll give you an example. So for this semantic search that I implemented in this MCP server, right? So if you look at the API points to a Cloudflare workers, and which is a vectorized DB. Imagine me cloning 100 repository on the MCP directly, and then whenever the MCP server is being asked one thing or request one thing, it goes through the 100 repo with their code, with their packages, and trying to look for it. Imagine that process, it would time out for sure. But because of this vectorized implementation, instead of it timing out, it sends in vectorized DB is just numbers, right? It sends in a number as a search, which is a semantic search, sending a number. And what it does with that number is try to match the number with something that exists on the vectorized backend. And if it matches, it is going to match faster than a raw query or raw text. So once it match, it gets a response back in no time. But the cool part is that it is not going to wait 100% for it. It will just automatically send the request. If there's any other thing the system wants to do, it can continue doing it while it gets back the request. So that way, it is offsetting or offloading that particular effort or action to whatever backend it is at the time, and then wait for it to complete, then return back to it. Meanwhile, any of these AI clients that you're using today, they are very strict a bit about the timing it takes, because they don't want to open client sockets or client what's it called? Consume, like there's a consumer action that happens, or streaming. Once they open a stream, the stream has a limited time for you to close that particular stream. But that's for a single stream. You can open multiple streams after the other. But the way Claude and all of these like AI clients built their system is that you can't open a stream for too long. It is going to time out. So those are some of the options that I've seen that have really worked with, because I've also faced the same problem with timing. And the interesting thing is that the way it will time out locally is the way it will time out in production, because I've tested it in production too. Because my expectation was that it's not going to time out in production, but I experienced the same thing. So you have to find a way to fix it even from your local. But I think just taking a look at this implementation or cloning this project and running it through Claude or any AI to analyze how timeout is being handled in this project, and you will see it to explain it to you, and you can use that explanation to understand how you can implement it in yours. So without having to go through the code one after the other.
All right, I really appreciate.
Yeah, you're welcome. And of
All
course,
right,
if you
so-
still face any error, please, you can DM me on Twitter. I'll be happy to help you.
All right.
Okay, great.
Thank you very much, Idris, for that wonderful explanation. And again, thank you everybody for joining. All right. So before we go, I would like to introduce us to our upcoming bootcamp that is starting by 1st of April. So I'm going to also rush this one because you're already behind time. So the bootcamp is all about AI engineering and backend development, right? So let me just do a quick presentation. So here we want you to become an AI backend engineer. The reason is AI engineering, as we know, is something that we build on top of a solid backend engineering system or a production-ready backend system. So if you don't have that foundation right, I think at some point you have problems scaling your AI systems. And that is why we have this particular bootcamp. So if you look at the curriculum here real quick, basically we are looking at teaching you the core of backend engineering and AI engineering in 6 weeks. And this is how it is being broken down. First week, we are going to focus on teaching you the foundation, like, JWT auth, validation, testing, structured logging, and, everything that you need to build a scalable backend system. And then on the second week, we look at introducing role-based access control, background jobs, external API integration, how to do these things properly, and then how to consume webhooks properly, in case you want to implement payments with Stripe and with Paystack and all of this. So we are going to have time where, we build these things and then we show you how it can be done. And then from there, we build that knowledge And then on the third week, we introduce scalability, like talking about Redis caching and the implementation, looking at rate limiting, looking at some security implementations and other things that makes a production ready. And then after this is done, on the fourth week, we look at building AI infrastructure. So we'll start by talking to you about vector databases, just like what Idris mentioned when he was talking about embeddings. And then we talk about document ingestion, which you call document chunking for rack systems. And then we look at building rack pipelines, and most importantly, AI agents, which is, of course, what you can use with MCP servers to actually implement a particular thing. And then, of course, we have a time for model context protocol, which is the MCP itself. And after you understand all this, the theory and some implementations, we are going to look at, actually using advanced patterns like human in the loop, agent autonomy, guardrails, some of the patterns that we know, like React and plan and execute, and many other memory systems to actually build out something. So the product we are going to be building is DocuSearch, which intentionally is going to include AI agents. It's going to include MCP and other rack pipeline and systems into one. And then at the end of the 6th week, we'll look at prepping you for hiring, of course, because one of our motto is making you highly paid and job ready. So it is always important in each of our boot camps that we prep you to become hireable as an AI engineer and also a backend engineer. How do we do this? We walk you through different mock interview processes and how to pass these different interviews. We actually have a platform where you can practice mock interviews. If you go to MasteringBackend.com, you're going to get access to it. And of course, you're going to bring in an expert that will tailor your CV, talk to you about different job strategies. And we already had like a workshop where we show you the person that we are bringing in. So if you are fully ready to join this bootcamp, of course, you can go to the website masteringai.dev. I'm dropping the link on the chat and register for it. It's starting by first week of April, so you can, get to it as quick as possible. So with that, like I said, I don't want to waste much time. If you have any question, always hit us at hi@masteringbackend.com. Just drop the email right here. And then here is also the website where you can get more information, even download the curriculum for this particular bootcamp, which is masteringai.dev. So with this, I want to personally thank our speaker today, Mr. Idris. Thank you very much for a wonderful presentation and also breaking down these terms for us and making us to understand how we can start and build our first MCP server. We really appreciate you coming. Thank you very much. All right, so with that, we've come to the end of this particular workshop. And please always remember that we have workshops like this every week. And if you look at our Luma event, you will see that we have another workshop on Spring AI. So this is mainly for Java guys. How do you build AI agents, AI systems using Java? And that one is going to happen next week. So I want you guys to also register. I will drop the link right here in case you want to check it out. luma.com/MB events. So you always subscribe to our events right here. And we always have events like this happening every week. All right, guys. So that is the end of this particular workshop. And thank you very much for joining. If you have any question, please reach out to Idris at OlanNetSoft on all social media platforms. Right? I hope I got that correctly, Idris.
That's correct. LearnSoft, yes, correct. Thank you.
All right. And this video is going to be out on our YouTube channel. There is going to contain all the links that is mentioned in this workshop, including how you can contact our wonderful speaker for today. So with this, I will say see you on the next event.